Hello students. Welcome to EduRev. Today, we will learn about Class 10 Science Chapter number 10, Light, Reflection and Refraction. So, let's light each other today. Have you ever thought of common wonderful phenomena we all encountered, like image formation by mirrors, the twinkling of stars, the beautiful colors of a rainbow, bending of light by a medium? These all are associated with light. Light in itself is a wonderful phenomenon. So, let's explore light and its properties, that is, reflection and refraction in this chapter. You all have already studied about reflection in bits and bytes in lower grades, so in this lecture we will start with studying the same, that is, reflection of light from zero to its zenith level. First and foremost, you need to solidify your concepts, in which I will help you so that all your doubts will be cleared about the reflection of light and you will be able to attempt any type of question asked from the same topic in your Class 10 exams. So, let's begin. By observing the common optical phenomena around us, we may conclude that light seems to travel in straight lines. We can take example of a small source of light, which casts a sharp shadow of an opaque object, that points to this straight line path of light, usually indicated as a ray of light. You know that a highly polished surface like mirror reflects almost all the light falling over it. Now let's recall the laws of reflection. 1. The angle of incidence is equal to the angle of reflection, and 2. The incident ray, the normal to the mirror at the point of incidence, and the reflected ray all lie in the same plane. These laws of reflection are applicable to all types of reflecting surfaces, including spherical surfaces as well. If we talk about the type of images formed by the plane mirror, these are: image formed by a plane mirror is always virtual and erect. Virtual image is formed when the light rays appear to be originating from a point, but does not actually meet. Erect image is nothing but a upright or straight image. The size of the image is equal to that of the object, as you can see in the figure that HO is equal to HI. The image formed is as far behind the mirror as the object is in front of it, as you can see that in the image, that wherever the object moves, image also moves the same distance. The image is laterally inverted, as you can see in the examples given over the screen. First image is showing that when the person raised his right hand, the image shows left hand. You can conclude that when you imagine yourself standing at the position of image, so this is known as laterally inverted image. Similarly, other examples show the same phenomena of lateral inversion. If we see around us, we can see mirrors other than plane surfaces as well, like rear view mirrors in vehicles, in which objects seems to be smaller than they actually are. These type of mirrors have curved surfaces, and it seems like as if these are part of some big spherical mirror. So let's explore these different kinds of mirror one by one. So first understand, what is a spherical mirror? A spherical mirror is a polished reflecting surface that is part of a hollow sphere of glass or plastic. One side of the spherical mirror is opaque, while the other is a highly polished reflecting surface. The reflecting surface of a spherical mirror may be curved inwards or outwards. A spherical mirror whose reflecting surface is curved inwards, that is, faces towards the center of the sphere, is called a concave mirror. A spherical mirror whose reflecting surface is curved outwards is called a convex mirror. You can see the concave and convex type of mirror on your screen, but generally what happens, we all tend to get confused and often mix up in concave and convex mirrors. Like which has inward surface and which has outward surface. So here is a trick to remember so that you will never forget it. When we are reciting the name concave, the word cave where early humans used live is a hollow structure, as we all know, right? Hence, concave mirror is nothing but an inward reflecting surface. Similarly, the opposite of it is a convex mirror which has an outward reflecting surface. You can also remember this with the help of a spoon, as the surface of the spoon curved inwards can be approximated to a concave mirror, and the surface of the spoon bulged outwards can be approximated to a convex mirror. Before we move further on spherical mirrors, we need to recognize and understand the meaning of a few terms. These terms are commonly used in discussions about spherical mirrors. Pole, the center of the reflecting surface of a spherical mirror, is a point called the pole. The pole is usually represented by the letter P. Center of curvature, the reflecting surface of a spherical mirror forms a part of a sphere. This sphere has a center. This point is called the center of curvature of the spherical mirror. It is represented by the letter C. Also, center of curvature is not a part of the mirror. It lies outside its reflecting surface. The center of curvature of a concave mirror lies in front of it. However, it lies behind the mirror in case of a convex mirror. Radius of curvature, the radius of the sphere of which the reflecting surface of a spherical mirror forms a part, is called the radius of curvature of the mirror. It is represented by the letter R. You may note that the distance PC is equal to the radius of curvature. Principal axis. Imagine a straight line passing through the pole and the center of curvature of a spherical mirror. This line is called the principal axis. Remember that principal axis is normal to the mirror at its pole. Principal focus of focus. After reflection, light rays parallel to the principal axis of a mirror either pass through a point, in the case of a concave mirror, or appear to diverge from a point, in the case of a convex mirror. This point is referred to as the mirror's principal focus or focal point. The principal focus is represented by the letter F. Let us understand the principal focus with an experiment so that you can actually understand what is principal focus. This will help you to understand and relate it to the real world. Hold a concave mirror in your hand and direct the light reflected by the mirror onto a sheet of paper held close to the mirror. Then move the sheet of paper back and forth gradually until you find a bright, sharp spot of light on the paper sheet. Then hold the mirror and the paper in the same position for a few minutes. The paper initially begins to burn, emitting smoke. It may even catch fire at some point. What causes it to burn? The light from the sun is converged at a point by the mirror, resulting in a sharp, bright spot. In fact, this spot of light is the image of the sun on the sheet of paper. This point is the focus of the concave mirror. The heat produced due to the concentration of sunlight ignites the paper. The distance of this image from the position of the mirror gives the approximate value of focal length of the mirror. Till now, you have understood the entire concept of principal focus and that how it works in real world, but now, let us understand the same concept theoretically also with the help of ray diagrams which can be asked in exam. A number of rays parallel to the principal axis are falling on a concave mirror. Observe the reflected rays. They are all meeting intersecting at a point on the principal axis of the mirror. This point is called the principal focus of the concave mirror. The reflected rays appear to come from a point on the principal axis. This point is called the principal focus of the convex mirror. The distance between the pole and the principal focus of a spherical mirror is called the focal length. It is represented by the letter F. A spherical mirror's reflecting surface is spherical. Thus, the surface has a circular outline. The diameter of a spherical mirror's reflecting surface is known as its aperture. For spherical mirrors of small apertures, the radius of curvature is found to be equal to twice the focal length. We put this as R is equal to 2F. This implies that the principal focus of a spherical mirror lies midway between the pole and center of curvature. Now, let's solve a very simple question, which will clear your basics a little bit. The question says, a convex mirror used for rear view on an automobile has a radius of curvature of 3 meters. What will be the focal length of rear view mirror? Now let's solve this. So as we just discussed that R is equal to 2F and given R is equal to 3 meter, F is equal to R by 2, which is equal to 1.5 meter. Hence, focal length of the rear view mirror is equal to 1.5 meter. Till now, we have understood about spherical mirrors, important terms related to spherical mirrors, experiment to find principal focus of concave mirror, and a formula which will help us to find the focus if we know the radius of curvature of spherical mirrors. It's time for you to first revise all the concepts we have just learned from the docs given and practice tests related to the same topic from EduRev app and start learning the further concepts from our next video. Thank you.